All right, good day, everyone. Once again, I'm back at it with the lessons. For today, we're going to be talking about two variable equations. Just kind of give you a little concept. Basically, what we're going to be talking about today is our goal is to create equations in two variables to represent relationships between quantities, as well as graph two variable equations. Okay. Once again, just kind of think about today's lesson compared to yesterday's lesson. Remember, yesterday we only had to deal with one single variable. We were talking about like having an x, and that was it. Today, we're going to be adding two variables. Okay. And the key thing you want to understand is that with two variables, we're going to be looking at things like an x and y equation. Okay. So let's go ahead and just get into it right away. First and foremost, just kind of so you can see them, I do have the keywords built where it's the same thing as last time. For keywords, if you are dealing with a variable, okay, we're looking for like per or each. Okay, these are going to tell us that it's not just a set number, it's a number with how many of those that we have. Okay, that unknown variable that we don't know just yet. And then the second portion is our value or our answer. This is going to help us describe the total or the per, okay? Oh, God. Hey everyone, today we're going to talk about two variable equations. In this lesson, we're going to be really focusing on creating equations that involve two variables as well as graphing those same equations, okay? To kind of compare this from yesterday's lesson, yesterday, if you remember, we only had one single variable that we had to deal with. Okay, for example, we just had to worry about an x value. Today, we're going to be dealing with two total variables, okay? That basically means that we're going to have like an x and a y, all right? To be honest with you, this lesson I almost feel is almost easier because I think it's things that you have seen before. An equation will pop up within this lesson that I'm almost certain that you have seen, okay? So let's go ahead and just talk about it. First and foremost, let's talk about keywords. Okay, just like yesterday, our variables in which we're actually going to be looking for this unknown number that's within our problem. Those are going to be helped describe with the words per and each, and our value or our answer side of the equation is going to be described with total or profit. Okay, so let's go ahead and read our situation. Today we're going to Sapphire Island. Visitors can rent inner tubes to use in several of the park's rides and pools. Maria works at a rental booth and is preparing materials so the visitors and employees will understand the pricing of the tubes. The renting of the tubes costs a flat fee of $5 and an additional $2 per hour. On items 1 through 7, the review the above problem scenario, carefully explore the target or carefully explore together the information provided and how to use it to create a potential solution. Okay, so let's kind of just talk about in general what they want us to do for problem 1. In problem 1, they have a chart here given to us, and we want to basically fill out this chart. We want to be able to use this and start to see the pattern in front of us. To do this, we have to understand what's been given to us in the problem, okay? So there's two pieces of information that they provided to us above here. There's a flat fee of 5 plus $2 per hour, okay? So when we're building this chart, we have to kind of think how much money are we spending from the hours that we're spending at this water park here? Well, we need to use these two numbers to help us out. First off, we have a $5 flat fee. $5 flat fee. As well as we have $2 per hour. So if I'm thinking about this problem here and just building out this chart, I could probably do this in my head, but let's just write out the math so we can see what's happening, okay? If I rent the tube for 1 hour, basically I'm taking the $2 per hour, I'm going to multiply it by how many hours I was there for, which was 1, and then a flat fee is basically how much money you're paying up front, okay? So there's really no change in it. Doesn't matter how many hours you have it for, that number is going to stay the same. So it is just 2 times 1 plus 5, which if I work this out, 2 times 1 is 7, or excuse me, 2 times 1 is 2 plus 5 is 7. I was a little ahead of myself there. So you kind of can see this process will continue throughout the problem. Okay, in the second box, if I rented the tube for 2 hours, all I would have to do is take 2 times it by the hours, which is 2, and add 5 to that. Well, if I think about that, 2 times 2 is 4, plus 5 would be 9. Now, if you continue going through this problem, you could probably do the rest in your head. Okay, 2 times 3 is 6, plus a $5 flat fee comes out to be 11. And then we have 13 and 15. And so basically, right now, we're just trying to figure out how much money are we going to spend on the tube throughout this day. Okay, it's kind of a nice thing to have, because if you're going to a water park, you want to know how much money you got to bring. Okay, if that tube's going to cost you this much money, and you're planning on spending this much time there, it's important information to know. So let's look at number 2 here. Explain how a customer could use the pattern in the table to determine the cost of renting a tube for 6 hours. Now, if you look at this chart above, you are seeing, or at least I hope you're seeing the pattern shown. 7, 9, 11, 13, 15. The pattern itself is it's adding 2 each time. Okay? That's the pattern. So if I want to sit there and say 6 hours of tube time, all I have to do is take the 15 and add 2 to it. So I know, like, okay, following that pattern, it's got to be 17 hours or $17 for 6 hours of tubes. And so that's kind of an important concept to start with. And I want you to remember, like, how this pattern is working, because it's going to help guide us throughout this lesson. Okay? Let's go ahead and continue on. The next portion here is an important piece of information. What does the independent variable represent in this situation? Okay? For this to be said, we got to talk about what is the independent and what is the dependent variables. Okay? If I'm talking about an independent variable, independent variables, we want to try to think about that as the variable that will not need anyone. So if I'm thinking about the situation, it doesn't need any outside source to affect it. Okay, it's always going to be in itself the thing that kind of describes what is happening in the problem. Okay, I always like to say it is the thing that we can control. If we think of like a word problem, it's what we can control. Well, if you really think about this tube problem up here, we don't really affect the cost. We choose how many hours we want the tube for. Okay? So in this situation, the independent variable is the hours that we are holding the tube for. Okay? It's what we can control. We can have the tube for 3 to 4 hours. Okay? But that choice affects something else in the problem. And that leads us to the second portion, which is the dependent variable. Okay? And the key thing to understand about this one is that this is what's affected. Okay? If I hold the tube for so many hours, what's going to change within the problem? Well, that's kind of the key point here. If I hold the tube for 6 hours, I'm spending $17. So the dependent variable is actually the cost. Okay? And the reason we use this lingo is because we want to be able to determine what can we affect and then what's the outcome of the problem. Okay, that whole idea of like cause and effect in math terms. Okay, independent is what we affect, it's what changes within the problem. The dependent variable is what is affected because of that choice. Okay, especially in a word problem sense, these are pretty important ideas. So with that information, let's continue on. Okay, we already talked about number 4, the dependent variable we did on the last page. So we want to try to create an equation here. Okay, we want to try to build an equation. And to do this, we have to think about how is this thing changing and how is it affecting. So first off, we want to build a 2-variable model, okay, where y is going to be our cost and x is going to be our hours. Okay, so see how we're building 2 different variables. Oops. Sorry about that. We're building 2 variables within our problem. Okay, y is the cost, x is the hours. So now all we have to do is kind of fill in with the same idea that we had on the last page. Okay. For this problem, we're going to have the cost, which is y, is going to be equal to, well, how much does it cost per hour? Well, it's $2 per hour. So I'm going to write that as a 2x. But the last thing I can't forget is my flat fee. So y equals 2x plus 5. $5 is the flat fee, the number that's never changing. 2x is the cost per hour. And then y is the actual cost of the problem. Okay? And what we've done there is we've actually built an equation using that. Now, the interesting thing about that is if we actually look at our chart, even though we didn't have variables, we kind of did that over here. Okay, we did that same process right here. Because if you really think about this, this is coming out to be 7 equals our math there. Well, isn't this the same as our y, because that's our cost? And that's going to be equal to the hour, or the cost per hour, plus 5. So you see, our equation is built off this information. Okay, we did this already, we just didn't plug in a variable yet. The only difference from that first page to this page is that we're just plugging in this little x to represent those hours. Okay? From there, we can start building some information off of this. Okay? For example, like for number 7 here, and this is kind of where the whole equation gets important. Explain how an employee could use this equation to determine how much to charge a customer. And while it seems like a pretty straightforward answer, this is the important part of math. This is where we really apply it to certain parts of our life, certain calculations. Well, if I'm trying to figure out how much I'm going to charge a customer, the customer comes up to me and says I want the tube for 5 hours. All I have to do is to plug that in. Y equals 2 times 5 plus 5. Okay. Okay, and let's say that, just to write that out. Oops. Let's say the customer wanted it for 5 hours, and we're trying to find the cost. Well, that's all we have to do now. We don't have to go through a chart. We don't have to go back and do all this work of trying to go step by step and trying to find the pattern. We can just go ahead and plug that right into the problem right there. And right off the bat, we can pretty much figure out that it's going to be $15.